Thanks everyone for coming, and this session is being recorded, so make sure to do lots of applause at the appropriate moments and ask awesome questions. Anyway, so I'm David Blevins, and I am in a company called Tommy Tribe, and we do a lot of stuff in the Java middleware space. We are one of the co-founders of MicroProfile. We also do support and things like that for various Apache, Java EE, and Jakarta implementations such as Tommy, ActiveMQ, so on and so forth. And this is Jean-Louis as well, so you can say hello because you both have a microphone.
Yeah, hello everyone. So my name is Jean-Louis Montero, and yeah, I've been working for Tommy Tribe for the last 5 years now. I'm going to be helping out David because he's usually not autonomous on that kind of presentation, so he needs my help.
Totally unable to do anything without this guy, which is kind of true. Anyway, so this is a presentation about MicroProfile JWT primarily. There is a presentation tomorrow that's more deep involved into the JWT and OAuth 2 space. But just so we can get a understanding of who we have in the room, and by the way, it's awesome there are more than 4 of you. That's pretty cool. Who is using MicroProfile right now? All right, we got a good like 7 hands there. That's fantastic. Who's using JWTs already? All right, we got another good hand. So who's not using MicroProfile or JWTs? Well, we're like split every single way here. Okay, well, we'll try to make sure that, that we cover all, enough to get you up to speed. And so, first of all, both of us are people who have contributed to the actual MicroProfile JWT specification. I wrote the text for the 1.1 version. Scott Stark of Red Hat did most of the work for the 1.0 version. And so we do a lot of stuff with security as well. So this talk is going to be, we're going to attempt to divide it up into 4 equal parts, which are all going to run over to make 50 minutes. So the first chunk, we're going to try and give a nice short overview of JWT without getting too far into the whole OAuth 2 thing. Then we're going to give a real brief overview of MicroProfile JWT and how to bootstrap a project. So how to get up and running with the least amount of code possible. Some sort of advanced concepts. We'll see how much time we have for that. And then demo of a full stack app with an Angular front end and does the whole login and refresh and all that. So we'll send you away with all this code so you can go grab it afterwards. So if you at any point get confused, we'll definitely ask questions because that's what we're here for, but you can check out the code yourself later. So first is basically the JWT overview. And so this is a JWT in its finished form, and ultimately a JWT is an identity token, all right? And when we go ahead and create this thing, the most important thing about it so far, the 3 parts of a JWT are header, body, and a signature, and I'm going to detail all of these parts, okay? This is not something you're going to create yourself. Typically, it's something you're going to have a product like an Apogee or Keycloak or something like that is going to create this for you. But the first part is the most important part, and that's the body, and that's that part in yellow. So effectively, all a JWT is a JSON map. Very not fancy. You take a JSON map and you fill it with data about your user. So someone's gone ahead and they've logged in, and at the moment they log in, your identity provider will take data from, say, an LDAP or a database or wherever you're storing your user identity information, and we'll throw that into the JWT map, to the JSON map. And then our job is, since we're going to distribute this around the network, we need to protect this thing, okay? So there, at the top of this thing, and by the way, this is a base 60, the stuff on the left there, that's the base 64 encoded version of this JSON map. all right? So it's not encrypted, it's publicly visible, it's base64 encoded. The top of a JSON Web Token is what's called the header. And the header is the instructions that someone receiving this token uses to figure out how to check the JWT. So I'll tell you what checking means in a moment, but here this one says that this JWT is going to be protected by RSA SHA-256 digital signature, all right? And it says the type inside the JWT is, of course, JWT. There are other forms. It could be a JWE, which is encrypted. And so instead of having a base64 plain text, you could have encrypted body on the inside. Okay? Then what happens to make a JWT is you take these two parts in their base64 encoded form, you hash that, you come out with a number. In this situation, it's a SHA-256. And then the most important part, we take an RSA private key and we encrypt that that hash. And then that thing becomes our digital signature. That thing gets thrown at the end of the JWT, and now we have a protected user identity data token. The important thing to know about this is that only the private key can make a token, and it's absolutely essential you do not distribute this widely across your enterprise, or you don't have an identity system. So you have one system that holds that private key very, very closely and dearly, and everybody who has the public key can effectively unlock that signature at the end and get the hash right out of it by decrypting that version of the hash, and then they can go ahead and rehash the yellow and the red parts and check the hashes against each other. That's basically how you verify a digital signature. So ultimately, a digital signature is like GitHub hashes that are encrypted. So that way, I know that the right person made this token because I know only they have the private key, and everybody else can be given the public key, which gives them the ability to check hashes, but it doesn't give them the ability to make hashes, right? So if I were to give you an analogy to stick in your head, if we were to imagine that you're at a football game, you can take that for whatever football you like, soccer or US football. The referee, if he or she wanted to protect the score, the referee would have a private key that they stick in their back pocket, and they're the only ones with that private key. When they call the final score of the game, they would hash that piece of data. They would get a SHA-256 number. They would take their private key out, encrypt it, put it back in their pocket. They would distribute the public key to the entire stadium. They would distribute that encrypted hash to the entire stadium along with the score. And if anybody wanted to check the score, what they would simply do is take the public key, decrypt that signature, look at the hash, compare it to what they see as the score. Obviously, they have to hash that data themselves too. And then they would compare the two, and if they matched, they know the score is true. If they don't match, then someone's lying about the score, and it's probably not the referee because they have the public key of the referee, and it doesn't check out to anything the referee said was the actual final score. And so this is effectively a way to create distributed read-only data that you can actually trust and verify without a network hop. So if you want more details about all that stuff, because that's a whole talk in itself, I'll give you a slide reference, but ultimately what you need to understand for this talk is that you're going to have an architecture that looks basically like this. You have like a gateway in there, which is an Nginx, or like I say, it's something that is usually your first hop. You've got your microservices in the back end. You've got your users. In this architecture, you will have one piece of the architecture that has that private key and is capable of taking users' names and passwords, verifying them, creating these identity tokens, then distribute them to users. Okay? There's a whole flow for this. OAuth 2 has it. And ultimately, now those users have their own signed identity tokens that identify them specifically. They cannot lose them. They need to be protected just like passwords. And on the back end, you would distribute that public key to the entire stadium, i.e. your microservices, and they then in turn can verify any identity token that they see at any moment by using the public key corresponding to that thing down there. Okay? And so ultimately, MicroProfile JWT is about this part of the puzzle. All right? It is about how do I get a private key, a public key installed in my server so that it can verify JWT when it sees it come in off the authorization header of HTTP requests, and then take data out of the token and put it into my application and ultimately just keep you safe. So it is not about creating JSON Web Tokens, it's only about verifying JSON Web Tokens. And much of MicroProfile is a cloud-native perspective, meaning it's attempting to hook in with already existing cloud-native things. So if you're in Microsoft, Azure, they have their own API gateway that creates JSON Web Tokens. If you're in AWS, they have an API gateway that creates JSON Web Tokens. If you're in OpenShift, I'm sure you can use Keycloak for creating JSON Web Tokens. And so, ultimately, you just need to be able to verify the JSON Web Tokens. And so that is the gist of what you need to know to understand the whole how tokens are made. But they're there to basically solve the problem of I get a request and now I go call some center point of failure to get some information on whether or not I should trust this thing. You can do that all within your microservice in a completely stateless way by just having the public key of the identity server installed in your microservice. So we're going to shift to the next section, and which shows you actual code. But before we do that, since this is a nice, clean 4-part talk, do you have any questions to answer or ask? Any thoughts, curiosities? No? Wow, I did an amazing job. Or are you just not brave enough? There you go.
Why is JWT much more, it seems like it's way more used than JWE. Does that encryption part really offer?
So the question was, why is JWT used more than JWE? It's a couple things. One is that usually that the value of being able to use, there's data in the JSON Web Token, and if you want to consume any of that data in the back end and that thing is encrypted, then you need to distribute encryption keys to the back end. And most of the time you're using some sort of symmetric encryption, and then now the same people have the ability to both encrypt and decrypt tokens. And so they're just not that common in practice. You definitely do find them when people are passing the JWTs out to untrusted areas, and they may have PII in them. And you'll definitely find much more encrypted things. It's actually possible with JWTs to encrypt. The fields inside a JWT are just a JSON map. So individual values could be encrypted, and the backend could go ahead and decrypt them if it has the decryption key. But ultimately, it's sort of like why isn't all data in a Java object private? Well, you're passing it to somebody who definitely needs to get something out of it. So in practice, you do find a lot of kind of public data in JWTs. Any other cool questions? Thank you for that, by the way. You get a point. We have shirts here. You're definitely going to get one. Well, everything has to get reinvented, so it doesn't have so it has the coolest, latest, greatest data format. So Kerberos is all like binary tickets and uses a lot of the same concepts. Sure, and then when SAML came out, people smelt a lot of reinvented Kerberos. SAML is basically a JSON Web Token with pointy brackets and a lot more size. And JSON Web Tokens are basically SAML with squiggly brackets instead of pointy brackets. And someday, someone's going to want to invent YAML Web Tokens. It's just going to happen. So we can all get used to it now. Okay, any other? All right. Thanks for that question, by the way. And then if you want to know the full architecture and how this works out, tomorrow I'm giving a talk at 12:30 p.m. And we're actually going to look at how this impacts our architecture in terms of performance numbers, load, impact on center points of failure, how we got here from the early versions of OAuth 2 that didn't have JSON Web Tokens, how to know to ask the right questions to make sure you're using OAuth 2 with JSON Web Tokens versus just regular old tokens, which are effectively a stateful architecture and seriously bad. So go attend that if you want to see all the network exchanges and messages on how these things are all obtained and refreshed and all the policies around expirations and so on and so forth. So that's tomorrow at 12:30, and then from there, we'll do the overview, and I'll hand it off to the very capable Jean-Louis, and he can lull you all with his amazing French accent. Ooh.
All right, let's switch. Okay, perfect. So we're going to be now focusing on the MicroProfile part of this talk. And we're going to see how we can create a simple project and use MicroProfile to consume the JWT token and secure microservice. There are different roles, different goals, sorry, for MicroProfile JWT. We do cover certain things. So for instance, we do cover the ability to parse and validate the JWT token. We do also provide a way to extract data from the JWT tokens. The key value pairs inside the payload are named claims. It's a fancy name, but it's just a key value pair. The specifications provide an easy way to get some of the information injected so that you can use that information for your own purpose. There is also a nice integration with Java EE, so you can use a role-based access control to secure your microservices and secure some of the endpoints if you only want to secure some of them. And finally, it's out of the scope to propagate out of the box the JWT token, but there is a way to get the full token so that you can handle by yourself the propagation to other services if you are consuming or if you are a client of other services. For those who came to the session this morning, I spoke a bit about the REST client specification. There is a way, if you are using MicroProfile REST client, to propagate automatically the authorization header and the JWT token if you are using both together. Now, what's not covered by this specification? So David already gave a bit that information. So the specification is only the consumer side of things. It does not give any way to create the token by itself. You need to rely on a third-party service, so an identity provider, an STS, if you have that. For the purpose of the demo, we're going to be using one that I'll be showing you a bit later. But you definitely need an external service to identify the user and generate the JWT token so that you can pass that into the service. There is no real way to perform JWT verifications or custom verifications, even though David is going to probably introduce some advanced usages of the specification and what we would like to push as the new improvements. So I won't enter into details, but David is definitely going to touch that area.
I'm finishing it right now.
Yeah, he's coding like crazy while I'm speaking. It's brand new, so it's not part of the specification, and it's not really done because he's still hacking on it. Anyway, and as I mentioned previously, there is no magic under this specification to propagate the token. So it's up to you to get that token injected and then add that as a header of all the subsequent calls that you're going to do. All right, so now how do I use MicroProfile JWT? So there are a couple of things that you have to do. First of all, you have to tell the MicroProfile container that you want to use MicroProfile JWT. To do that, you have to basically annotate the JAX-RS application, for instance, with @login config, and use the MP-JWT authorization method. That's the trigger, basically, to switch on the extension and make sure that all incoming requests are going to be checked and the JWTs validated. And then, obviously, you have to tell the extension where is the key. So it relies on MicroProfile config for all the configuration. There are many ways you can pass in the public key for the validation. You can use the value by itself, and you can use the location, which is a more common way to configure the keys. The location can be any ClassPass location local to the JVM. It can be any HTTP remote URL if you want to. And well, it can be any URL handler that you have on your JVM, basically. So as soon as you do that, yeah, go ahead.
You know, it's the interesting thing is that's the only acceptable value for that at this moment in time. And sure, yeah. So ideally, we actually kind of don't need that annotation in the future, but I mean, we sort of shoehorned it in for this moment. And turning it into annotation is a great pull request. So by the way, this is all open source. And honestly, that's a perfectly valid you're going to love the part of this presentation later, because I hate strings in code as well. So yeah, but seriously, come to the project and just submit a PR or open a request or something like that. I mean, code is better than requests. Love it.
You get a T-shirt too.
Yeah, absolutely.
All right, so that was for the configuration part. Any other question, by the way? Nope. In terms of runtime, so as soon as we
Why don't you show the demo code?
Yeah.
Yeah. So basically, those are the three methods that use it. You have a roles allowed for restricting people's by permission or role or group. You can all fight internally inside your organizations whether or not you want to do by permission or role or group, and you can all have big religious wars over that. But meanwhile, it's just a string, so you can put whatever strings you want in there, and then ultimately, @claim allows you to pass data from the token into the code. Go ahead and pull up some code.
All right. So this is a sample, like the basic sample that you can really implement. So there is in there like a simple REST endpoint. Yeah, go ahead. I can make it bigger.
Yeah, there you go.
Yeah, sorry about that. So there are a couple of things in this sample. At the end, we're going to give you a link so that you can check out the repo and run that locally. So what I'm going to show you now is just a simple starter project. So the bare minimum you have to implement in order to make use of MicroProfile JWT. So as we mentioned previously, there is this kind of trigger to switch on the extension, and we have like the movie DTO, which is the object we're gonna pass in and out the REST endpoint. And obviously, the interesting part is the resource itself, with 2 endpoints, one to add a movie and one to get all the movies. They make use of the roles annotation, which is going to basically check if in the JWT token you have the manager or the user role. And if you want to add a movie, you have to be a manager. You cannot be only a user. As I mentioned previously, everything relies on MicroProfile configuration, and by default, with MicroProfile configuration, there is a file named MicroProfile config, where, is that big enough? Where basically you can specify all the properties you want to get injected, and the MicroProfile JWT specification relies on MicroProfile config to configure. So what I'm saying with this MicroProfile public key location is that I want to use the public key which is defined in a file, which is production pub, which is the public key that I want to use to validate the signature. You won't be finding any PEM file or private key, because this is not the scope of MicroProfile JWT. Remember what David said, the private key is inside the identity provider, inside basically the service which is going to create the token itself. But you definitely don't want to spread the private key in all the services, and even less if you are running on the cloud. So that's the public key only. Now we have a test that is going to make this bigger, which is an Archelian test. And the test is going basically to call the endpoint with either the manager role and the user role, and then we also try to invoke the service with only the user role, and then we want also to make sure that if we call the service and we don't have any token, we're gonna get a 4-1. So that's the client part. Now we want to use all of that into an automated test. So what we're going to do is we're going to rely on what MicroProfile gives us. And with MicroProfile, you can basically provide another MicroProfile config file over here. But you can define a new config ordinal, which is really a specific entry in the file that allows you to basically say, well, I want to override the default one with this one because the default ordinal is 100, and I'm using 101. So this one is going to basically override the value of the MicroProfile config property that you have over here. And in this one, what we do is like we say, well, I don't want to use the production pub key, but I want to use the public key, which is under test, so that I can have the private key to use and create valid tokens in the test itself. Is that clear or not?
Go ahead and open it up.
Yeah.
So the advantage of here is that you usually have the issue of, do I have test credentials and things like that when you're. The great thing about JWTs being entirely a stateless piece of secure data backed by keys is you can make your own test credentials and use your own test private key and test public key, make your own JSON Web Tokens in the test portion of it, and then run with your own mocked up JWTs. In production, you would obviously not use your test private key and test public key. You would use the actual production public key. And so you are able to 100% test security in your environment without any external systems. It's pretty awesome. It was never easier to do this than now. I mean, like, but before you'd need an LDAP system or some other garbage, and now you can just go ahead and make a test token, send it into your app, see that it's rejected, and then know that that's going to work against the public key of the real server at runtime.
So to run this example, we're going to use Apache Tommy. Who knows about Apache Tommy?
You're all supposed to raise your hands.
Yeah, exactly. So Apache Tommy is one of the MicroProfile implementations. It also implements more stuff from Jakarta IE or Java IE. And we're going to be using Apache Tommy for all our demos today.
Go ahead and run it.
Yeah,
Show them the green bar.
Yeah.
That's what everyone wants.
Yeah, I actually love
Oh, you
the
should
black
run it from
screen
your
with Maven.
IDE. It's way more sexy.
Yeah, well, let's do both. Okay, so I've got a build success. We've got over here the invocation with the logging from the JAX-RS calls. And let's say that I want to use the IDE to run that, just to make sure that David is happy. And I hope that it won't break the demo.
And if it doesn't work, then I have mine set up.
Yeah.
Apparently, you've got some compile errors.
Yeah. So you wanted to really make
I mean,
mess
you
up
know,
my presentation.
demos are not fun unless something goes wrong, right? Okay, so here's the same thing over. I will open it up. Okay, same test case. And so this is just the basic claim 1. And go run. And then, of course, it's all going to fail horrifically badly just because that's required. No such luck. So it worked. So, you know, ultimately, you know, if you want to see this fail, right, we can go into our test public key and we can like mess with it. I just changed a character, right? We run this again and we should get some pretty nasty output saying that the world is not as we expect it to be. There we go. So the security is actually working. If we do not have a validly signed JSON Web Token, stuff does not work, and that is the expected outcome. And so, you know, that's the pretty cool part. Maybe you want to show the claims injection.
You have that already on the screen.
Oh,
but
I can do it.
Switch.
Here,
It's actually now working again on my computer. So
go ahead.
yeah, right. I don't know why IntelliJ messed up the previous execution, but
And we'll do that one, then we'll switch to the fancy stuff, and then we'll do the full stack demo.
yeah, absolutely. So as we mentioned earlier, there is the ability to get some claims from the token and get that injected, so you can make use of it inside your business code. So in this example, we want to get with CDI at inject, and with the client qualifier claim, we want to get the email from the token, and then with this endpoint, we want to return the token to the user.
Return the email, yeah.
Yeah. So this is the test notification email that you can see over here, and at the end we are expecting to see Jane Awesome, because that's the email we've got in the token. Again, if we want to mess up with the test and change the email in the token, we're going to get a red on this one. So there are different ways to get a claim from the JWT token. You can get, obviously...
All tests passed. Did you run the right test?
Oh, yeah, probably.
That was the previous one, I suspect.
Yeah, that's the previous one. Absolutely. Anyway, there are different ways to get the token. So you can get the row type. I probably changed the bad one, so never mind.
Okay, well, it works but
yeah.
better than it should.
So you can get the row type either way, a string, an integer, or any row type. There is another way to get a claim. You can use the claim value, which is a wrapper, where let's make this a bit bigger. So this is a wrapper where you have the name of the claim and the actual value of the claim, and it extends the the usual Java ET principle of the JVM.
Yeah, we added, we made it so JSON Web Token in MicroProfile extends principal interface so it can be used anywhere in an EE platform where principal is currently returned. So for example, in servlet get caller principal, you could cast that thing to a JSON Web Token interface.
So that was the second.
Yeah.
5. Yeah, we're gonna run quickly. So that was the second option, and finally the third thing that we wanted to show and demo is the third one, which is the ability to get the full token as a principal and as a strongly typed object, which is a JSON Web Token. When again you use this JSON Web Token, you get a subclass of the principal, and from there you can get obviously the name, and you can get all sorts of things like the issuer, the audience, the subject, and all that stuff. And you get also the ability to get a claim by providing the name.
Right,
basically.
so any custom claim that you'd want, you can just go ahead and grab it. So ultimately, JSON Web Token is like a map interface.
So in this case, for instance, if we want to get the email again, we'll get the full token over here, and then we'll use the get claim method to retrieve the email. Questions, or can we get into more fancy stuff?
So by the way, all this stuff is available on GitHub. One of these projects is a separate repo that is a GitHub template project, meaning you can launch off another project using it as a template, and it just has those 3 objects and the right configuration. So all you would really have to do in the real world is just paste in your public key of the production server. You could leave the test keys and you're off and running. So, you know, that is a really valuable resource. Okay, so
Go fancy now.
now we have the fun stuff. I mean, not that that wasn't fun. Go ahead. They can be hierarchical, so you can put whatever you want in the claim. Ultimately, there are no restrictions. The question was, are claims flat or they can be hierarchical? And so the answer is there are standard claims, and it's recommended you do not use those names in an unstandard way, but you can use as many other names as you'd like and put all sorts of stuff in there. Yep. Absolutely. So you were saying migrating from something like Kerberos where there are hierarchical things involved. Yeah, so you could have your field be another JSON web object, you know, so a token could have a JSON object inside it. Doesn't have to be a string or a Boolean or whatever. MicroProfile JWT does support the @claim injection with data types of course, string, Boolean, float, you name it, but also supports JSON P objects, so JSON array, JSON object, and so on and so forth. So you could get a real rich data type injected into your code. You had a question?
Yeah, so about the claim names that you mentioned, that there's some, well, there's no restrictions, but we should follow, like there's certain reserved claim names.
Right.
So how does this go in conjunction with OpenID Connect? Because they also have some reserved claim names.
So the question was, how do the reserved claim names that I'm talking about map to OpenID Connect? And the answer is they're the same. So for MicroProfile JWT, we deliberately attempted not to conflict with any standards. We're only doing the minimum amount of work to enable the most implementations out there without stepping on anybody. So you can use all the standard claims. The JSON Web Token interface has this enum of a whole bunch of standard claims. Many of them come from OpenID Connect. And it's just to let you know as a user, hey, there are a bunch of standard claims out there. If you're going to use them in a standard way. Outside that list, make stuff up. Okay. So, advanced concepts. So, what we've seen so far is pretty cool. It's awesome. It's a great 1.0 feature. But considering JSON Web Tokens are data objects, right? They have a lot of data. It's not like the old world where someone just has roles and we only need the @roles allowed annotation, and that satisfies 100% of our needs. And so the curiosity and the question here is, could we use bean validation to basically give us a pass-fail on the JSON Web Token? Do I like this token or not? Right. So who's familiar with the bean validation specification? Great. So those of you who are not familiar with it, the bean validation specification ultimately allows you to put annotations on your data objects, like your JPA objects, and then to get them verified to make sure all data inside that is good before you persist it to the database, right? And so very similar concept could apply here. So here we have a demo of a feature that we implemented in Tommy where we have our standard @roles allowed annotation, but I also want to verify the issuer is the one that I want. And so in my own project, I have a bean validation constraint that I made called issuer, and simply it accepts JSON Web Token, calls the get issuer on the JSON Web Token, and validates that it is what I expect. All right? And I have another one that I can use to validate the audience of the token, so the AUD claim. And ultimately, the idea is that you could write any bean validation constraint that you want, as long as the constraint implementation takes JSON Web Token as the thing that it validates. You can go ahead and make your own annotations. So here's one that should theoretically reject any calls that don't have the appropriate movie issuer, right? So if I just go ahead and say test valid issuer, this of course should succeed, assuming that things are going well. There we go. I always say that things go bad just so in case they do, it's like I planned it. Doesn't always work that way. But anyway, so if we go ahead and change that, right, I'm just going to delete some stuff, run that again. It should fail my bean validation check. What is the deal? Oh wait, this test that it was not yeah, it's a 403. Okay. It says invalid right in front of me. There we go. That's the one that should fail. It helps when you read, you know what I mean? That's one of the problems when you're up here as a presenter. You miss the most obvious things because you're worried about all the other stuff. Okay, so that one failed, right? And if I put it back, it'll succeed. So you're going to have to trust so that it does. Now, that's a small example. Now, bean validation allows you to make your own annotations for absolutely anything. And you can put any kind of data you want inside a JSON Web Token. So here's a pretty crazy example where we're going to use Japanese to do role-based restriction, right? So I gave this a little presentation in Tokyo, and they just thought it was awesome. So this is effectively role, or as I understood it from Google Translator, role. It may or may not actually turn out that way, but and then so, that one, I forget, is maybe manager or user. I don't recall. But ultimately, we have our test case, which has that claim inside the token and has the appropriate values. And if we run it, it should pass. And then, of course, I'm going to go ahead and delete that, and it should fail. So I will yank out all the roles just to, because I'm not exactly sure which one to delete, because I don't remember. And then we go. We got a 403, and the test failed. So you can do anything you want. I was literally chatting with some people the other day, and they're like talking about, oh, should the roles allowed annotation, is that all of these have to be in there or just some of them? And they go, oh, it's just some of them, and that's industry standard. And I was like, thinking to myself in my head, it shouldn't be. I mean, you should be able to decide what you want the requirements are. And so this would allow you to basically figure out, what do I want from a business perspective and not have to copy and paste all that code all over the place. You're using standard bean validation annotations. And that can get quite fancy, right? So here's an example of a really over-the-top movie service. And our friend in the back is going to love this because I have a strongly typed annotation with no strings, and it's safe for all the developers to smear this all over the place, and they're not even duplicating anything because bean validation has this cool concept where I can inherit other bean validation annotations. So here is what movie token looks like. It says, all of these claims have to be there, man, and if you don't have them, you're not coming in. So you could actually, for your business, load that token up with critical stuff that has to be there and reject all requests that don't match. And so if we want to go ahead and show that this works, I'll go ahead and take a picture. As long as you tweet it, that's the price. Okay. So here we have a valid version of such a token. It's got all the stuff that we need. We will run this one, and it will, oh, we're out of time. We got 3 minutes left. No? We don't. Okay. All right. So that went ahead and succeeded. And then if we do this same one without all the stuff in there, that will go ahead and fail for us. Well, I mean, the test expected failures, but if we look at the output, it basically said all the claims that we were expecting to be there are not there, and that's why it gave us a 403. So before they kick us out of the room, let me give you the GitHub location where this is at. By the way, I just mentioned tomorrow there is a customer type of a real-world case study of someone who implemented MicroProfile and MicroProfile JWT in the Brazilian medical industry, and it's a very awesome example of how this stuff can actually be done in the real world. So if you want to see case, type of thing, go ahead and do it. Other than that, right there, all the code is in that bottom URL. Okay, I don't think that QR code is correct. So you can use it, but that will be other awesome code. Okay, so we have no time left, but I'm sure if we ask a couple questions, they'll live with it. Anybody? All right. Thank you so much, and hope you enjoyed the session.